Hello, everybody. I'm going to speak for about half an hour on building what-if models in Excel and Power BI. In fact, more about Excel than Power BI. I realize my place here. I am just the warm-up act for the real stars, which is Chris and Rishi, and they're going to be talking about Power BI. And I don't want to compare my limited knowledge with their uber knowledge, so I'll sidestep that and talk more about Excel models. And thank you, everybody, to our sponsors and to the other speakers. And why is this in the middle? Let me just tell you what it is telling me something. There we go. That's good. You don't see that. We can switch it to. Yeah, we can switch it to whatever we want. Lovely. Great. Fantastic. Thank you. Good. So this is a session. We'll talk about what is a model. Is every spreadsheet that we build, every Power BI report, is that a what-if model? We'll talk about that. I'm going to start just talking about, for those of us who are not accountants, who haven't been looking at kind of income statements since kindergarten, who did useless subjects at university like physics, like me. Is anybody out here not an accountant? All right. Oh, there's a few of us. Good. That's good. That's good. Okay, just if we're starting with models, and I'll talk about why the classic fee statement, income statement, P&L is a good place just to get started. We'll talk about scenario modeling, which is where we've got uncertainty about the inputs and we've got a kind of variation in the results. Scenario model and sensitive analysis, I'll try and explain what I think is the difference between those two. Then we'll come on to a technique called Monte Carlo simulation, basically running lots of trials and simulations based on kind of random variables taken from what we think our inputs are going to be. We'll look at the nuts and bolts of that with games of chance, throwing a few dice, playing roulette, and then we'll apply it to the kind of financial model. The application is actually very easy, but we'll go through the steps of a Monte Carlo model. And then some final thoughts on once we've got this model, how do we communicate it and visualize it? The model's only useful if people take account of it. So that's the plan. I'm going to talk for about half an hour. I've got my thing down here, and Chris is going to give me a big 5 at 10. If make it 10:45, Chris, and then shut me up completely at 10:50. Lovely. Okay, that's what we're going to do. I'm talking about Excel, and if you've used Excel, it's been around forever. And you may or may not have noticed that it's improved quite a lot over the last few years. So, for example, we recently got functions called Let, which allows you in the formula language to use variables, which is great. We can start writing using the formula language, and we don't need to use VBA. Do you know that VBA was the most popular language 20 years ago, and now it's about number 20? So, and possibly for good reason. It wasn't the best language, but it was useful. So we've got LAMDA that allows us to write our own functions. So we've got quite a lot of new functions and new techniques out there, dynamic arrays. I'm just going to mention them in passing. And this talk is really a talk about what's possible. It's not exactly a how-to talk. If we want to, we can come in and look at some of the underlying Excels. I'm going to be showing you the PowerPoints, but if somebody really wants to know how a data table is or what a LAMDA formula looks like, we can do that. But I'm going to stick on doing let's do a Shift F5 to get back there. We're going to be looking at kind of PowerPoints and a kind of how-to. There is a very famous statement, I think it was by a statistician called George Box. You can Google me and tell me I'm wrong in a minute, but it says that all models are wrong, but some are useful. Now, the models that I've got, I promise you, are definitely wrong and obviously wrong. They're quite simple teaching models, but I hope they're going to be useful in kind of suggesting how we might use Excel to build or at least to prototype a model. And I ask the question, does Excel spreadsheet, every Power BI report, is it a what-if model? Probably not. I mean, most of the Power BI reports I write use historic data, and they gain some insight into that historic data, which we might use for our decisions going forward. But I'd say a what-if model is essentially has got future dates in it. And when that works, we're kind of predicting or planning for the future. So, and we're trying to estimate, forecast an important result. In the models I'm going to be doing, the result is going to be we're looking at the income statement is going to be the net profit. We're going to, as well as that result, get the most likely result. We might want to say what can possibly go wrong, how much is our upside, so what's the best case. And so we'll be looking at scenario analysis, sensitivity to do that, and then Monte Carlo. And especially with Monte Carlo, we want to say, okay, this is our likely profit, but we want to know the probability of something going wrong. For example, in what it would be in a financial case would be what's the probability of us making a loss? I was talking to some people in hospitals, and their kind of break case was when they'd have no capacity, no hospital beds. So it could be an operational thing as well. And we're going to talk about when we know some of our inputs we don't exactly know what the values will be. They're outside our control. So let's go. So this is one of the really basic examples we're doing. I told you they were simple. We're going to take a company income statement. It's the smallest income statement you've ever seen. This company makes $1 million. We've got some costs of goods there that are subject to the inflation rates. We know that's out of control. We've got, the company's got a loan from the bank, and the bank is putting in the interest rates, so that changed the interest. And of course, corporation tax changes from day to day, changed yesterday, who knows what it's going to be tomorrow. So those are three things that are completely out of our control. Those are what I'd call the variable inputs to it. So in our models, what I'm going to do is kind of make this distinction between fixed inputs, things that we're relatively sure we know the numbers for, which I've got on the right there. I mean, for somehow we know that our sales are definitely going to be $1 million, give or take. We know exactly the size of our bank loan. And then what I'm going to call the variable inputs, the green things on the left there, inflation, interest, and corporation tax, which I think, as I say, recent events show that they are very variable indeed. So that's what our model is going to be. And what we have, I'd say, with the what-if model is we have a cascade of calculations. Those red and green circles on the outside are our initial data, our inputs, and then they create calculations like our projected COGS, and then there's a cascade of calculations down to our final, most important results. All roads may lead to Rome, but all arrows here lead to our net profit, and that's what we'll be looking at. I talked about why the kind of free statement model, income statement, cash flow statement, balance sheet are really useful if you're getting started. Here's an example of this. I've just been looking at Chris's pack, and he's got some fantastic Power BI examples, so I hardly dare show these. And these are built in Excel, but the good thing about these is if you're getting started and you don't quite understand because you haven't done it, why a balance sheet balances, then it's really good to build one of those. You get a really good understanding if you're not an accountant. The other thing about this is a couple of things. First of all, doing something like this teaches you that everything is driven. The final sheet there on the left would be an assumption sheet, and everything on those three statements is driven by the assumption sheet. What I've got there is those cells in orange. I'm using the kind of Excel styles to show what's a data input cell and what's a calculation cell. And there's our data input, and if we go back to our there, we notice that everything is a calculation. And also, if we look at the calculations, there's lots of interrelated calculations between the sheets. So, for example, the net income flows through to the cash flow. It also flows through to the profit and loss sheet, and to the balance sheet. From the balance sheet in red, it flows back. The accounts payable flow back to the cash flow, and the debt flows back into the income statement. So we get a lot of interrelated statements. So if you are getting started with models and financial models, then this is a great place to start. It's also really basic Excel done well. It just requires kind of fixed and relative addresses. It doesn't require any of that modern Excel that we've talked about. Okay. In Excel, if we're doing what-if analysis, then something called data tables is the workhorse. And it allows us to run a model repeatedly for all sorts of different inputs. Let me explain with a formula here. And what we've got here is a snapshot of an Excel page, obviously. So what we've got is a model to calculate your body mass index, BMI. It's a very, very simple model. It's basically your weight divided by your height squared. And so the good thing about BMI, though, about a data table, though, is that we can have very, very complicated formulas, very, very complicated models. I've chosen a simple one, and it will just work as well. So where it says possibly some intermediate calculations here, that there would be a lot of stuff there. So what we've got is we set up just a sample case, somebody with a weight of 70 and a height of 1.7 meters, and we go through the model, and it gives that result cell of 24.22, just there. And what we then do for the data table is we have to create this table. We put our heights in a column on the left. We put all the possible weights we might want to use in this table in a row on the top. And then we can build this data table, and it will give us all the values. So it's a very good way of running the model lots and lots and lots of times. This is a simple example, and of course, everybody will say, well, I could do this quite simply with a couple of structured references, but imagine that we've got really lots of calculations between the weight and the height and the BMI. So data tables are great for that. They're a bit fiddly to set up, and if anybody wants to see them, I can show them how to set up. It takes about 3 or 4 minutes to set it up, first of all. You can't enter the formula directly. You've got to go through a dialog box, but it is worth it, as the advert says. They are worth it. I'm going to talk about scenario modeling. So far in the model I just showed, the free statement model, we got our results out, but we got the most likely results for our projection, but we had no idea what the kind of range of values would be. And scenario modeling tries to do that. It sets up a few plausible scenarios. Typically, there might be the best case, the base case, or the central case, and the worst case. And it puts inputs for those 3 cases. And then and then we calculate those 3 cases on a loan. So typically you might get best, base, and worst case. So I was talking again to the health service, and they talked about the base case, but they also talked about a COVID wave case that they were doing and a heat wave case. I don't know if they have a COVID wave and a heat wave at the same time. That would be a bit ridiculous, but there you go. Financial regulation, if you've been involved in that, they never look at the upside. Regulators are only interested in what can go wrong, so they'd have a base case and a worst case and a severely adverse case. The good thing about this is, what we'll talk about in a minute, is that what you've got these 3, each of those cases has a story behind it, and it's easier when you've got the results to kind of explain to stakeholders what they mean. A couple of ways in Excel to do it. The one on the left is that we can do, here I've got this simple income statement model. Again, I haven't showed that. Well, I have here, but basically you can have each case side by side with a simple model, or tab by tab. You can do all 3 models at once. The slight problem with that is you've got 3 sets of the same calculations, where obviously there could be some inconsistency. So you could have a kind of a switch approach where you come over here and you've got a kind of, you can switch between, oops, that's not what I wanted to do. I want to switch between scenarios. And then you can just switch, and then I can switch between the worst case and the best case. I'll get my numbers at the bottom. What happens there, once we click on the worst case, it will put our variable in, the worst case variable inputs in the start of the model, and just calculate the model through. I'll just talk about the table approach as well, because this comes on when it's not particularly useful here. But what we can do, Excel has now tables, and we can write structured references in those tables. So if you've got a model that we could actually build it in a table, simple enough to do that, you can see that this is all the things lined up, net profit on the right-hand side. And it's actually, this is the approach that we can use with Power BI. Power BI, of course, is based on tables, and it's really good for Monte Carlo. So we've got a possible third approach there, which is a table approach, more of which later. Sensitivity analysis is all to do with just taking 1 or 2 factors and changing those. It's much more kind of specific technical detail. Let's have a look at an example here. So what I've got is I've got my model there working out my net profit margin, and what I'm saying is I've got the 3 inputs, inflation rate of 9%, interest rate of 6%, tax rate 20%, that's my base. And then I've got down here, I've if you can see that, I've got say, well, using these data tables, what happens if the inflation rate changes? It's no longer just 6%, it goes down to 5 or up to 13. Again, you can see the interest rate as that changes. We have a much more effect on our net profit margin. That's what we're trying to do. And then what we can do is, I'm going to hide that so we can see that. We can also look at it both and have a combination of interest rate and inflation rate. So we can have 1 or 2 dimensional sensitive analysis, a more structured, more detailed, more specific, but we can isolate each kind of variable and see how it affects in place. I'm going to talk about a bit about Monte Carlo. First of all, to recommend a great talk about Monte Carlo, I run something called the London Business Analytics Group. We had a lot of virtual meetings during lockdown, including this one from Professor Mark Whitehorn. He gave a really good 40-minute talk explaining all the concepts of Monte Carlo, and I really recommend it to show that if you've got 50 minutes. But basically what we do in Monte Carlo is we take a brute force approach. We run lots of trials using different variables that simulate the kind of variability in our variable inputs, and then we try and aggregate over them. So what I'm going to do in my model is that I'm going to use 3 different inputs. I'm going to say that my bank interest rate varies between a minimum and a maximum, and it's kind of uniform. So the bank interest rate could be any value between those, and it's got an equal chance of any value between those 2 rows. That's called a uniform distribution. I'm saying my corporate tax rate, well, if Rishi Sunak had got in, it would have been 26%. Now that Liz Truss is in, it's 19%. But when I was doing this, there was a 60% possibility of it being the kind of default rate of 20%. That's a discrete distribution. We've got 3 different possible values, and we've got a different percentage for those. And finally, what we've got is a distribution called the normal curve, which is basically, we say that our kind of mean, our average is 7%, and this is our inflation, and our standard deviation, our spread, a measure of our spread, 2% or 1% either side. I've chosen these because these are really easy distributions to set up in Excel. So those are our distributions. Let's just hop along. And so we can start doing, what I'm going to do is just talk about how we can implement Excel here with, very simple. We'll talk about just rolling or throwing dice, and then we'll talk about running a roulette wheel, and then we'll apply it to finance. So normally with Monte Carlo, what we're doing is we can't work out an analytical solution, so we use Monte Carlo. Of course, here we know that rolling a dice, the analytical solution is obvious. That is going to be, a third dice is going to have the same chance of rolling a 1 or a 6 or any number, basically. But what we do with a single dice is that I've got 3 methods here that I want to show. First of all, one is just, I'll actually just go to it. In fact, why don't I do that? I'll actually just go to Monte Carlo. Let's have a quick look. Monte Carlo final. Let's go to that. There, let's go to this. So we've got a trial here, which is just, we're using a function called rand between that will give us a value between 1 and 6. What we're going to do is we're going to run it 100 times. I'm only running it 100 times because I've got so many trials and so many different Monte Carlo trials running. If I run them all 1,000 times, it'll slow it down. So we run it, and then we just calculate with these countifs. This would be our summary. So running it 100 times, we should expect to get about 16, 17 for each, but we're getting about, it depends. Of course, if we did 1,000 or 10,000, the law of large numbers means that the percentage difference is going to come towards what we expect the theoretical one to be. But I'm just running it 100 times. So the first one I'm doing, and the reason I'm doing this is simply I just want to show 3 options. The first one is just, we're going to run it 100 times, we've got a range there, and we can calculate. The next thing I'm doing exactly the same, but I'm doing it in an Excel table. And the good thing about doing it in an Excel table is that when we look at doing the summaries here, we can see this countifs. It's a nicer formula. It's saying just count we've got a table, that table is called the third die table, and that column is called die 1. We're just going to count those. Lastly, what I'm going to do is going to use a data table approach that I talked about. Again, really, really simply. And what I'm going to do here is I'm going to say, here's a die. Our model result is exactly the same number. This die is our model is just a run between, and then running that data table 100 times. So showing those three implementations really. Let me just go to my two fair dice here. And of course, what we can do then is once we've got one dice, we can play Monopoly with two dice, and roll them two. Here what we've got is Monte Carlo trial of that. We've got our first dice and our second dice. We've got them, and then the result is our total. And then we're just plotting that. Again, we can see what we get if we throw 100 dice. I've done exactly the same here with a table, and the slight advantage is that the summary functions are easier to read. And also maybe also the calculations, we can use these kind of structured references. It's not saying, for example, H25 plus I25, it's saying the first dice plus the second die. And then again, what I'm doing here is I'm running the Excel data table. Here's my model. I've got my two inputs, die1, die2. I've got my results, which is summing them, and I run that 100 times. And if I come over to see, even with 100 rows, what we can do, if I just go to formula and just click on calculate the sheet, every time we do that, it calculates. This is our theoretical one that we can work out very easily based on, we can work out, here's a table of all the possible combinations of those two dices, and since each one has an equal chance, we can combine that. So even with 100, we're not getting anywhere near our theoretical distribution. We can see that. We obviously need a bit more. Now let's do a bit of cheating here, and let's find out, let's have a dice, for example, that is cheats. Basically, it's got a 10% one chance of giving you a 1, and it's got a 25% chance of giving you a 6. And again, so what we're going to do, how would we do that? And we can't no longer use our rand between. So what we have to do is use a function like rand. That just gives us a continuous random number between 0 and 1. And then we're using the formula here with like this ifs, and like the ifs rather than if, because we don't need to nest anything, which is basically saying it's, if the random variable is less than 10% less, then it's going to be a 1, and so on. So we can simulate a dice. Again, we're simulating it in the 3 different ways. Let's have a look at our trial. That's our trial, and that's our model now in our data table, and we can do that. So that's an example of the discrete distribution corresponding to the kind of tax rates that I talked about. So once we've done that, we can play a bit of roulette. And just to remind you of the rules, just in case you don't pop down to the casino every night, basically there is this roulette wheel here, and here's a picture of it. Let me actually just go back to my slides. Actually, let me just do that. And I'll just go back because I think I've got better slides there. There we go. We've got a roulette wheel here. Notice we've got that green 0. That's the house advantage. There's a set of sockets there on that wheel, all between 0 and 36. And you place your bet, you get dressed in your tuxedo or whatever. You go down to Monte Carlo, you order your martini, shaken, not stirred. You place your bets on the roulette table there, either on a particular number, or you can do red or green, red or black, or you can do the first 12, the last 12, and so on. So we are going to play a bit of roulette with Monte Carlo, and the moral of the story is that Monte Carlo will show you never win. You knew that already, didn't you? Absolutely. So let's stick to these, and let me just check the time. Okay. So we're going to play Monte Carlo here, and we're going to run a roulette simulation. Now let's say that what we're doing is that we are also betting not just on, we've got a variation of roulette in our house, where we bet not only what the ball lands in, but when we bet on the time it takes for the ball to come to a complete stop. And that happens to be a normal distribution of about 7 seconds, give or take 1 second. So sneaking my normal distribution in there. So we're playing roulette, and we're playing various strategies. And again, what we can do is we can run lots of trials. So here I've got the first 10 trials of 100 or 1,000. And what I've done is I've chosen, first of all, a lucky number. My lucky number is 22. And what I'm going to do is I'm going to come and for 100 sessions every night, I'm going to put my €1 chip, €1 because it's Monte Carlo, on 22. And what I can do, so I've got this strategy one, betting on 22, and I can run it 5 minutes, thank you very much for that. I thought you were saying, I'm going to bet on number 5 there. I wasn't quite sure what you meant by that. And so what we can do is we can run that Monte Carlo. I also can bet on red, and I can also bet on the time it takes to do that. So what I can do is then run it, and then I can come in and simulate what happens if I go into the Monte Carlo every day next year, from the 1st of January all the way to the 31st of December. I place my bet on 22 100 times during the night, and whatever I do, I'm always going to make a loss. This is the summation of 365 days, 100 sessions, and I'm always going to make a loss, whichever strategy I use. Some nights I'm up, some nights I'm down, but I'm always going to make a loss. So let's see what that looks like when we go to our Excel. And what I'll do is I'll go to my finance model, Monte Carlo. Lovely. So having said all that, the Monte Carlo model is really simple to implement. So what I've got here is I've got the base case, just as we saw before. That's a standard base case for my project, or my thing, and that's my net profit margin. What I'm doing with Monte Carlo is I'm setting up the base case exactly the same, but for each of these, so if we have a look at the inflation rate, what I'm saying is, if we have a look, we've got an inflation rate of 12%, give or take, a standard deviation of 3%. I'm putting in a little calculation there. I'm saying, go and get me a value from a random variable with an inflation rate of 12%, give or take 3% is giving me, in this case, 8.64%. That's inflation. Yeah, that's right. What I've got here for my uniform distribution is, I'm saying, give me any interest rate between 6 and 8%. It could be any number equally spaced. And what I've got here is I've got my discrete distribution. And I just need to set it at once. That's a great thing about this particular model. I just need to set it at once. And I've got, in this particular, 2.7%. I could come along to my calculate sheet and run it, hit that basically 10,000 times. Or what I could use is I could use my data table here. Again, I've got a data table doing, I've got a data table doing, I think, just 1,000, but I could run it. And that shows the kind of the advantages of data tables. So I've got 1,000 data tables. And then what I've got is, I've got those 1,000 results. I can look at what I'm going to get. So on average, it's telling me I'm going to make a 2% profit, but I can also do things like I can count what's the risk of the loss. And the risk of the loss is simply how many trials yielded as results of net profit less than 0, apart from the, divided by the total number of trials. So Monte Carlo, really easy to do in Excel, and it scales up. If I had time, I would talk about how we can scale that up to Power BI, but there are better people than me to do that. I'll just go back to my PowerPoint slides and just go to the end and talk about any of dynamic Monte Carlo. But yes, a couple of really good things. First of all, it'd be good to talk about maybe once we've got this, it's kind of, we've gone through this, and it's quite a kind of detailed, technical, almost wonkish approach. So one of the good things with Power BI is that we can visualize it really well, and we can kind of explain our results, some of the storytelling that's talked about there. And a couple of really good resources. One really good resource that I'll recommend that was kind of helped my thinking about this. A really good book, Financial Modeling Excel, and a website by Daniel Steinfairhurst there. Good. And with that, I'll open to questions. Thank you.
I'm just wondering if you've built these models using the Excel data model to store your data, or do you normally keep your data within the worksheets?
I've kept my data so far within the worksheets. What I wanted to show very, very quickly is, let me just go to this if I can. What I was going to say, you can use Power BI for some of these models, I'm sure. One of them, let me just go to, if I've got it somewhere, yes, so let's have a look. Let's bring this up. So, for example, there was an equivalent result in Power BI, and one of the good things about Power BI, if I go to the next one, is that we can you can write some really useful DAX here. I'm not going to quickly show it, but to really scale up. So with data to create a calculated table to do all those trials, to do the base of those trials, that works, and that was really scalable. I was able to build Monte Carlo models of about 1 million rows, rather than at a certain stage Excel is going to run out. In that sense, obviously being Power BI, it's within a data model. But no, I hadn't used Excel data models with Excel. But I don't think there's nothing to stop me doing that. I'll have to think about that. Yeah. Good. Thanks for your question.
Where's the closest casino to here? Any other questions? Yeah.
Can we apply this model to anything else? I mean, what else is it suited for?
So are we talking particularly about Monte Carlo? Or are we so Monte Carlo is suited for lots of things. Right? I used to work in oil and gas, and it's kind of guess how much oil there is in a particular reservoir. You've got certain inputs, so to produce a model, that. But anything where you're kind of predicting, you've got variable inputs, and you're trying to predict what happens. It was developed originally by a mathematician who was playing solitaire, and he wanted to work out rather than what's his chance of winning, and he realized that so basically he couldn't work it out analytically, but what he could do if he had a computer, he worked out, which he didn't because it was early 1940s then, he laid out the fact that if he had a computer, then he could run enough games of solitaire and then again work out the percentage of games that he won.
Great, thank you.
Thank you.
Fantastic. Yeah, I mean, are you able to share any files with?
Yeah, I can share some of them.
Brilliant.
Great.
Okay. I'll send them all around afterwards as well. I'll make sure I collate all the content and all the links. So yeah, definitely good to follow up on this actually.
Lovely.